At this point, I would like to apologize for a moment, because a lot of the previous speakers have stolen my thunder. Big down the pecking order of presenters. Unfortunately, we have to deal with the penalty of having to avoid duplication. So if you excuse me for this, I will hop, skip, and jump through my presentation in order to make it meaningful and in order to avoid boredom. First of all, I would like to introduce Wartsila to you. You're all fully aware of Wartsila, the engine manufacturer. This is, of course, absolutely true. Wartsila, however, has got a very broad spectrum of products that have actually been developed as part of the portfolio due to acquisitions in recent years. One of the major elements of the Wartsila business to date is environmental solutions, and this has been developed based on the Hamworthy acquisition of 2012. So enough about the propaganda relating to the corporation. As a business ourselves, back from the Hamworthy days, we did recognize that it's virtually impossible to meet the ballast water treatment demands globally for a fleet that is traversing the oceans of the world in very different climatic conditions and very big differences in terms of sizes and itineraries. Therefore, we decided that the only way to move forward is by means of developing two technical solutions. Today, we market two technical solutions under the broad name of Aquarius. Wartsila Aquarius, it is a technology that we'll sell and comprises of two technologies, one of them which is based on filter and UV, and the second process, which is that of Aquarius DC, which is side stream electrochlorination accompanied by filtration. Both systems have been successfully IMO tested and type approved. Both systems already have a US Coast Guard AMS acceptance. Our system on UV is already fully accredited with ATEX and IECEX credentials, and this is shortly to follow for the EC system. At this point, I'm very fresh off the press. I will say that last week, we also obtained full ATEX and IEC certification of our factory in the UK for the development and marketing of the solutions. As part of the original content, I had some aspirations, but as I said, I will jump through this. However, at this point, what I would like to do, we talk about ballast water. Many of you don't even know what it looks like, and neither did I a few years ago. But this is what it looks like. This is ballast water, untreated ballast water, as it has been sucked by the pump, and it has been delivered into a sampling pot during our shipboard testing back in 2011. This is water that was drawn up from the sea chest in the port of Southampton. What you actually observe is a significant number of small jumping organisms, which is all the biology that we have to deal with, but simultaneously observe in the background in the slide a lot of sedimentary material, which is sand, broken shells, elements of sediments from runoff from land, and significantly some fibrous material that also represents plants. So the challenge that we have to deal with is quite significant as vendors and developers of technology. If we do not control the sediments, which is part of the Ballast Water Convention under Regulation B5, then the net outcome of that will be the presence of a significant amount of sedimentary particles in the tanks, and you can see on the top left picture, and just an indication of sediments being brushed out after an opening at the bottom of a hull in a river vessel. The other pictures, in fact, represent elements of findings from DMVGL, from whom I have to give the credit for that. They are pictures taken in ballast tanks where the biofluorescence, the colors that we actually see, represent the life biology of organisms living in the ballast tanks, in the sediments. So moving on, this has already been covered. Two international regulations, one truly international, one local, one already in force, this is the US Coast Guard, and the IMO, which is just waiting on the wings. With regards to the available compliance options, I have already heard that we have got the type-approved systems as being an element of the ultimate solution for the problem. What we must not forget that this in the interim, we do still have ballast water exchange, as far as the IMO is concerned, and equally landside reception facility as a possibility, and thereafter, of course, it is the option of no discharge. In the United States, as Gary Crute has already mentioned, we do have the AMS, the use of fresh water that has been drawn from the domestic public water supplies in the US and Canada only, landside reception facilities, and of course the no discharge. Looking into the future, however, we have got diminishing options. As the regulations are kicking in, the only viable options that remain, it is the ballast water management systems as a primary solution and no discharge. And in the case of the United States regulations, we still have the type-approved system under the US Coast Guard rules, the use of public water supply from freshwater sources, and the no-discharge option. Moving forward, the overall framework of the IMO and the US Coast Guard is based upon a set of guides and rules. Typically, with regards to the IMO, we're making reference to the G8 and G9 regulations. I will not elaborate on this. And equally, on the US Coast Guard, there's a whole series of very nicely written documents in American English, I might add, that actually challenges even myself when I read them. Almost incomprehensible sometimes. But anyway, let's move on. The technology challenge was seeking to move. The three guys here were actually the vendors. What are we seeking to do? They are trying to address a global problem because ships are not operating in a single area. They do not deal with water that has been drawn during one season. There are seasonal effects in the level of organisms and the content of water. Just to give you an example, the Klaipėda Sea in the Baltic between Sweden and Finland, in the winter time it is almost fresh water, in the summertime, in the wintertime is salt water. In the summertime, spring and summertime, is virtually brackish and fresh water. And the reason for the changes is because of the melting of ice from the snowfalls and everything else. So the runoff from land is quite significant. We also have to deal with the water and physical conditions in terms of chemistry, and what we must not forget, the critical part of this is the environmental conditions on board ship. This is equipment that has been built to be used on board ship, and not as equipment that has actually moved from land onto a ship, because then we have got failure. There are many examples of land-based solutions that have migrated to ships, and they have really failed. So, the regulatory framework for the type approvals. We have already seen that we have got two special frameworks. One of them, the more recent one, which is the USCG with the ETV and the IMO G8. There are some significant difference between these two protocols, list of which is the fact that under the G8, we can only test in 2 salinities and get a certificate for 3. Under the US Coast Guard rules, this is a no-go option. We have to test in all salinities where the certification has to be met. We also have to carry out something which is also important. It is an O&M test for 10,000 cubic meters or more. Under the the G8 regulations, there is no such requirement for operational and maintenance testing of the systems. There is a significant difference also in terms of the hold time regarding the process. The US Coast Guard or the ETV rules dictate a minimum of 24 hours, 1 day. The G8 code talks about 5. And so on and so forth. Typically, however, I think that the two general provisions at the bottom are the ones I would like to draw your attention to. First of all, with regards to toxicity. Formally, within the ETV protocol, there is no requirement for the toxicity evaluation in a prescribed way of a ballast water discharge. However, the IMO, under G9, has got a much more rigorous framework, in my view, which is based around all the rules, regulations, and the means by which the GISAM committee is actually operating. So I think, although we do hit over the head the G8 as being inadequate, etc., we have to give credit to the IMO with regards to the toxicity evaluations and post-treatment evaluations of discharges. Is, I believe, more superior to what exists in the American rules. And of course, at the end of the day, the other thing which is significantly different, when we did our IMO testing, yes, we were there operating the systems. Nobody told us not to. They were independent facilities, but we did operate. On the other hand, what we actually have is, under the ETV protocol, this is no-no. You give the keys and you run away. It's like just taking your car into a garage. You give them the keys to your car and you just wait for the bill to arrive. That's exactly how it works. Now, returning back to the type approval process. Globally, for all industrial products, irrespective of whether these are for land or shipboard evaluation, the type approval process follows the route to demonstrate compliance to a preset number of standards and levels. And when you have satisfied these minimum standards as stated by the rules, then you can obtain your type approval. Ultimately, the statement that we have to draw from this is a type approval does not guarantee performance. This is based on what we currently do. We do not guarantee performance under any regulatory framework of type approval rules, whether it's CE marking in Europe or US Coast Guard or IMO. So, Wartsila again, we have got an EC system. Our EC system is one of those that rather silently has slipped through the net. We did not respond to the original request from INTERTANKO. You have to be excused. I have to blame the spam finder on the email for that. However, I have to say that as a supplier, we have already not only launched our LOI. If you follow the time map, you will actually see that we have already completed the requisite type approval testing for our system in 3 salinities at the DHI facilities in Denmark. And some results, just for a little bit of a teaser. We have exceeded all standards that are shown in the green bands, as stated by the ETV. And on the biology conditions, what I have actually circled is the outcome of the biology of our system performance in the 3 salinities as per the standard. So we're well within what we're supposed to achieve. So from the point of view of the regulations, the Ballast Water Convention ratification, as it has already been mentioned, is considered to be imminent. So there is only one way to deal with this, is to be prepared and to be proactive. I will skip at this point and introduce to you the Aquarius Ready phased approach to retrofits. It is a fairly simple model where Wartsila proposes that the retrofitting of ships can take 2 phases. At this precise moment in time, the majority of ships do have a dry docking schedule. You will do a lot of work. During that period of time, it would be important, if you wish, to also consider the installation of ballast water management systems, and therefore carry out the early levels of work that are actually required for the installation. And then you can carry out the installation of ships, of the equipment later, pictorially. This is what you currently have. This is what you prepare as phase 1. And later on, when you're ready to install equipment, this is what you do. You just install the equipment. It's a non-brainer. It is a phased way to spend your money. You don't have to go dry dock and spend everything at once. So, what is the message? Unfortunately, there is a lot of pessimism in the market. We all seem to be facing the horizon. It's like this big storm that this captain is facing. However, I would like to leave you with the thought that we have to keep calm and cultivate an air of unrelenting optimism in order to progress. Thank you.